Hi guys, today I want to talk about the topic of simple harmonic motion. Firstly, the name is completely stupid because I don't think it's particularly simple to understand, but that's what it's called, simple harmonic motion. This is part one, and here we go. So what is simple harmonic motion? Well, before we start, let's just start off with some terms that we need to know. So period is defined as the time taken for one complete oscillation. Amplitude is the maximum displacement from an equilibrium position. Frequency is defined as the number of oscillations per unit time. Now, angular frequency, and it's not W, it's omega, is defined by the equation omega equals 2 pi f, where f is the frequency of our system. It is thus the rate of change of angular displacement measured in radians per second. And if you're not sure what a radian is, I will post a video on here just explaining what radians are, so keep an eye out for that. Phase difference is a measure of how much one wave is out of step with another wave, and how much a wave particle, or how much a wave particle is out of phase with another wave particle. Okay, so what is simple harmonic motion? It's an oscillatory motion, like a wave, where the acceleration acting on an object is always proportional to and opposite in direction to the displacement from a certain fixed point. So let's just have a look at an example. So this is a pendulum swinging here. Now maybe the fixed point might be the rest position of the pendulum. Now the further away the pendulum is from our fixed point, the greater the acceleration towards the fixed point. Now this is a defining equation for simple harmonic motion. We've got A, and A is the acceleration on the object. Now you can see that minus sign there. The negative sign means that the acceleration is in the opposite direction to the displacement. We've got our angular frequency, and it is squared, and we've got x, the displacement from the fixed point. So with the negative sign there, the acceleration always acts in the opposite direction to the displacement. Now, a solution to the equation, to the simple harmonic motion equation, is this: x equals x0 sine omega t. Well, what's x? Well, x is the object's position, or the object's displacement at a time t. X0 is the object's position at a time equal to 0. Now, one way of thinking about this is you can think of it as being the maximum amplitude of our system. What's the furthest away our object is going to get away from this fixed point? We've got sine, so you should be familiar with the sine function. And then we've got angular frequency, and we've got time in seconds. So the proof of that x equals x0 sine omega t is a solution to the equation a equals minus omega squared x. Okay, well firstly we need to think about what's acceleration. It's the rate of change of velocity, and what's velocity is the rate of change of displacement. Okay, so acceleration is really the rate of change of the rate of change of displacement, which I know sounds confusing, and this is where simple harmonic motion is not that simple to understand, but I'm not lying. Okay, so x equals x0 sine omega t. Now if I differentiate that with respect to time, okay, to give me velocity, I get this: velocity is equal to omega x0 cos omega t. Okay, if I do this again, so now I've worked out what velocity is in terms of our little equation. If I do it again, okay, to find me the acceleration, so if I find the derivative of velocity with respect to time, I end up with a equals minus omega squared x0 sine omega t, which is exactly the same as x, which gives me minus omega squared x. Okay, here's some more equations that you're going to need to learn. So v equals v0 cos omega t. So v stands for velocity at a given time. v0 is the velocity at time equals 0. We've got cos. we've got the angular frequency omega, and we've got t, time in seconds. Another equation that you have to learn is that velocity is equal to plus minus, because the motion could be to or from the fixed point. Okay, the angular frequency, and it's inside the root of the displacement or from a fixed point at time equals 0 squared minus the displacement from the fixed point at a given time. Okay, so x0 is the maximum displacement from the fixed point, and then x is the position at that time. And if you think about an object like maybe a oscillating spring or something, when it's furthest away, okay, x0 squared and x squared are going to be equal, so they'll actually cancel each other out. So the velocity at that point when the spring is furthest away is actually just going to be 0. Okay guys, I hope you found that useful. Don't forget to like, comment and subscribe. Hopefully now you want to go over to part 2. Is this simple? I'm not sure. Okay, bye for now.